Ben, thanks for being here. We are seeing increasing pressure for global emission regulations. What are the key challenges the engineers are facing today?
One of the key challenges that we're facing is that from November 2026, the Euro 7 regulation introduces a big step forward for onboard monitoring. It's known as OBM, and essentially OBM systems must continuously track particulate matter and detect when emissions exceed 2.5 times the legislated limit. That driver warning feature is new and really raises the bar for real-time onboard emissions control. And it builds on the earlier onboard diagnostics, or OBD, which focus more on detecting fault rather than actually warning the driver when there was a specific problem at a specific limit. And this is why accurate validation methods like MSS2 with its photoacoustic method are so crucial. Essentially, they offer direct, fast and specific soot mass measurement that ensures quality validation of challenges like OBM PM.
Like Chris mentioned, these sensors were largely used for failure detection rather than actually reporting real-time emissions, whether the parts failed or actually functioning properly. So let's talk about those sensors a little bit. So the sensors are a resistance-based electrical sensor that the signal changes as PM actually gets deposited on that sensor. And so once it reaches a certain point, the sensor needs to undergo a self-cleaning mechanism, a regeneration, in order to get it back to an ability to actually be able to report the emissions. This results in having some intermittent periods of data, no data sort of thing from the sensors. And we were working to try to improve that. But in comes a use case for the MSS2 that allows it to complement that hardware, the PM sensor, with a virtual sensor through the use of a model. So it's a soot load model that is calculated and calibrated using the MSS2 to really improve the accuracy and the precision of that OBM type value that's coming out. And so this allows OEMs and sensor manufacturers to ensure compliance with that OBM reporting requirement and ultimately more confident in the data that is being generated. This confidence is not really only based on only data in the laboratory, but the MSS2 is designed such that it can be put in the vehicle and extending the use and range of that model development through real-world operation of a vehicle. Its portability, its ease of installation, the reliability of the MSS2 really makes it the go-to choice for in-vehicle soot-based emissions testing. That allows us to limit the occurrences of any false failure associated with a GPF or a DPF, with ultimately has detrimental consequences for vehicle calibrators.
We talked a lot there specifically about development of PM sensors in vehicle, but we're also seeing a growing interest from OBM sensor manufacturers in developing lab-based end-of-line test rigs suitable for quality control purposes. Those kind of test setups are critical for ensuring the quality and reliability of OBM sensors before they're installed in the vehicle. And as Euro 7 places stricter demands on in-vehicle sensor accuracy, for emissions monitoring, robust quality control becomes essential. End-of-line rigs help manufacturers verify sensor performance under controlled conditions, reducing the risk of those in-field failures that we were talking about previously, and improving compliance confidence. And it's a key step forward in making sure that complex OBM systems work flawlessly in the real world under real-world driving scenarios like they have to.
Yeah, Chris, we're seeing this shift to real world versus laboratory measurements. And this end-of-line use case, it becomes part of that to add confidence in those sensor-based measurements. And that really emphasizes repeatability and durability of the MSS. It's really more than that traditional development tool. We're seeing it function as a quality control device for sensor manufacturers, not just the vehicle manufacturers, but they're working together with synergies, providing confidence to ensure that the data that they're getting is robust for the entire system, and it meets their own product requirements, validates them, and also meets all the requirements of their in-use customer. And that really creates a sense of continuity from the data that's generated in those sensors versus all the way back to the data that's generated in the model development of sensors on the vehicle that comes from there. So using the same MSS2 photoacoustic technology, building confidence in those measurements. So we see a growing use case of the MSS2 as a quality control measurement device in that scenario.
As mentioned, the MSS2 is based on a measurement technique called photoacoustic spectroscopy. So the measurement relies specifically on a tuned laser. So sample gas is exposed to the tuned laser, and any black carbon that's present within that sample absorbs the energy from the laser. The absorbed energy then heats the black carbon particles, which in turn heats the air surrounding those particles, causes expansion and generates tiny pressure waves, which are then measured inside the detector using a very sensitive microphone. The method is very selective and only black carbon absorbs that specific laser energy, so the resulting sound precisely reflects the black carbon mass concentration, which allows us to measure based on an interference-free technique and determine the quantity of black carbon within the sample. Unlike traditional opacity or smoke meters that register all of those light-absorbing particles, commonly referred to as smoke, this MSS2 is a real-time detection method that isolates black carbon and soot and delivers meaningful data needed for today's stricter emissions regulations. And that's independent of whether we're testing diesel, gasoline or natural gas engines.
Yeah, Chris, it sounds like there's some pretty cool physics happening inside the MSS, and it's interesting that it's really fuel agnostic, which aligns with much of our technologies for compliance in vehicles today. So let's talk a few more details about the MSS. So it's really designed to help our industry meet ever stricter regulations, and it does that by having a really low detection limit. Its range goes all the way from sampling 1 microgram per cubic meter up through 3,000 milligrams per cubic meter. That's quite a turn-down ratio for a measurement device, so that's really cool. And that allows it to have a suitability over a range of applications and emissions emitting things, whether it's engine out development or tailpipe compliance that's there. Addition just the measurement capability, it has a wide dynamic range that's been significantly improved over its predecessors. It's IP34 rated, allowing it to be used in RDE that addresses environmental conditions which the measurement occurs with the device. And regarding its serviceability, it's got really smart features incorporating an exchangeable sensor unit, which allows the user to essentially hot swap the entire drawer. That reduces downtime, simplifies testing, really lowers the overall total cost of ownership of the device. So these features make the MSS2 a reliable, future-proof tool for PM-related emissions topics.
Where do you think the MSS2 is having the biggest impact on a day-to-day basis?
Better filter technology means cleaner air and healthier cities, essentially, which is positive for everybody. The MSS2 is a big part of that progress, delivers precise soot measurements so engineers can continue to optimise filter performance and keep these systems working at the top of their game.
Manufacturers use these particulate filters to achieve near zero tailpipe emissions. And developing models and things incorporated with those particulate filters to understand loading mechanisms, regeneration strategies, that's really how the MSS gained notoriety over the years, and that was in early days of diesel particulate development. As that technology has increased, so has the refinement of the MSS leading to the MSS2, and now we can see that use in gasoline engines that also are incorporating gasoline particulate filters, which has really been introduced in Europe for the past several years, and we're seeing that more widely adopted throughout the US as regulations are upcoming at those near zero tailpipe for both light duty and medium duty vehicles in the United States. Yeah, so building on that foundation established by the original MSS and the MSS Plus, the MSS2 allows for that higher resolution of that GPF or DPF soot model to really take advantage of that MSS2's low detection limit that we talked about, its faster response time. What this all means, it's really the go-to instrument for this application. It is an industry standard. So now we can use that same instrument in the laboratory again for that development, and then take it to the vehicle application with ease and further refine, add confidence, add detail to those models, something that was more difficult historically with the legacy instruments. And this again looks at application in MSS2 as a quality control device. Really important, a paramount objective for our industry, to have confidence as you get closer and closer to zero, tying back to that OBM that we discussed, to OBD levels that we have. It's just really important and applicable for internal combustion engine vehicles.
And mentioning that, Chris, what do you think is the major change happening in the US? Tell us more.
We're seeing growing pressure from the US, and the EPA is actually mandating a significant reduction in the PM limit. So they're reducing the limit from 3 milligrams per mile, and there's a 6-fold reduction to 0.5 milligrams per mile, and that's across light duty and medium duty vehicles. That change starts to phase in from 2027 and will continue all the way through until 2032. and it's a massive tightening compared to previous standards and brings real challenges for manufacturers.
Yeah, Chris, this is certainly an interesting and challenging topic. 2027 is right around the corner. OEMs, testing laboratories are really faced with these challenges and asking a lot of questions. What do we need to do? Do we need to do something differently to achieve these levels? We've been using the same collection method for years with minimal changes as the regulations continue to get lower and lower and lower. So it really becomes a real challenge. In this methodology, we collect PM on filter media, and then you look at the loaded mass after the test, and you compare that to the unloaded mass prior to the test, and that's really your PM emissions with some other calculations that come into play. However, when there's nothing on that filter, per se, you're mathematically looking at the difference in two large numbers, which creates a high level of uncertainty. When you combine that level of uncertainties with the inherent uncertainties of filter handling, with CVS background contribution, you can really start to see where risk and measurement uncertainty stacks up, and as you get closer and closer to zero, this becomes a challenge. So in comes the idea of the Micro Soot Sensor. If we install that at the tailpipe of the vehicle, you can get a really nice quality control measurement. You know, are the numbers that you're getting out of that CVS-based filter measurement, are they really just noise or are they real? So now you have a real-time instrument to complement that filter-based measurement to add confidence. You know, was it a false failure because I didn't see anything with the MSS? We talked about its low-level precision. Or did I see a spike somewhere and it is indeed real? And now we really know where it occurred because the filter-based batch measurement doesn't tell you where it occurs. So we're allowed to pinpoint the areas of those problems where calibrators, development engineers, test engineers can really say this is the area that needs refined, limit the risk of false failures, understanding those true failures, and then take that back and either further refine the product. And it really all adds clarity and confidence to our certification testing at these near zero levels.
And interestingly, we're also seeing some interest and potential applications of the MSS in other industries too.
So tell me more, which other industries?
So I'd say the main industry that we're seeing a growing interest at the minute in MSS2 is for marine and shipping applications. So as with automotive, the interest seems to be arising as a result of growing legislative pressure, and that's particularly in sensitive regions like the Canadian Arctic and Norwegian sea ice areas too. So as Arctic sea ice retreats, shipping traffic's increasing within the Arctic region, and that's then raising concerns over the environmental impact. One of those concerns is black carbon, which we've been discussing throughout this talk today. And black carbon emissions actually accelerate ice melt through the combination of surface darkening on the ice and also atmospheric heating. So that causes further disruption to an already fragile ecosystem. Regulatory pressures mounting to impose stricter controls through emissions control areas, sulfur limits and also fuel bans. And the marine industry has got to start balancing that growing demand against the climate impact and also safety in this environment.
Yeah, Chris, that really sounds like an interesting use case that our industry is facing. I think the AVL's MSS2 is purposely built to tackle these growing challenges as such in a marine environment. It can build upon its ability to deliver fast, accurate black carbon measurement under challenging conditions, onboard conditions. You know, in that marine vessel is quite challenging due to its wide range of unknown things. But thanks to the robust design of the MSS2 and its photoacoustic technology, you can add confidence to this device. By selectively pinpointing black carbon in real time, the MSS2 can give ship operators, regulators around the world the data they need to monitor that compliance, to optimize fuel choices, to minimize those black carbon emissions perhaps, and really overall minimizing any climate impact it has in these areas. It's easy to install, works seamlessly across different vessel types, really makes it an ideal tool for meeting these highest emissions control standards while protecting any sensitive waters in these environments.
To the end of it, what do you think makes MSS2 the go-to choice for OEMs and engineers in general?
It's a really good question. We've talked about its different use cases and its robustness over the years, but I really think the MSS2 is so vital, building upon AVL's evolution of measurement technologies over the years. We've incorporated the MSS2 into this 20-year product life cycle of the MSS family, being trusted using the advanced photoacoustic spectroscopy, well utilized by our customers, some really cool physics inside of it, delivers rapid, robust, precise soot mass data benefiting our customers from there. Whether it's being used for developing filters and soot models, validating the compliance that we talked about, It allows you to really push emission standards in automotive and marine markets to the limits with its low detection levels. And it's providing critical, high-quality insights needed to meet those demanding measurement needs.
And on top of everything Ben said there, I think it's really important to recognise as well that one key benefit of choosing AVL as your testing solutions provider, our commitment is solely to delivering accurate, traceable and robust measurement solutions. This independence means that we serve the entire industry, so OEMs, suppliers, research institutions, academia and regulatory bodies, and essentially we ensure that the data that we provide is trusted and unbiased. Ultimately, our focus is enabling customers to develop cleaner, more efficient propulsion systems and meet increasingly stringent emission standards with confidence. And I feel the MSS2 is a great example of that philosophy and a valuable tool for our customers.